Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today, a very straightforward question, easy to solve in the realm of pure substance analysis. We are to determine the volume occupied by 2 kilograms of steam at 1000 kilopascals and 500 degrees Celsius. So very simply, we have a system, box, container, a tank that has only water inside, only steam, only H2O. It is at 1000 kilopascals and at 500 degrees Celsius. We know after doing all these problems on thermodynamics that this is probably going to be superheated, but we can be sure, right? What's the game plan here? The game plan is, given that I know two thermodynamic properties, I can grab any property I went from the state, right? I can grab enthalpy, I can grab specific volume, I can grab internal energy, I can grab entropy, I can grab all these different properties, right? And because I have the mass, I can relate the idea of specific volume, because specific volume is nothing but the volume divided by the mass. So if I'm looking for the volume, that's exactly what I'm looking for. I can simply do that the volume is going to be specific volume times the mass, right? So as long as I can find specific volume using my tables and multiply by the mass, which I know, I can find what's the volume occupied by this water, right? So game plan is, let's first find out what is the state that we're dealing with, though this screams superheated, and then next we're going to calculate the volume grab the specific volume and then calculate the volume using it. Okay, so I have steam tables for water here. We are at 1000 pascals. So let's go, this is the temperature table. Let's go to the pressure table. You can use either, it doesn't matter. I think that students usually do a better job with the pressure table because it's easier to understand. And right here we have 1000 kilopascals. So this is where we are at, if of course we are at a saturated state, right? And we can see that at 1000 kilopascals, the saturation temperature is 179.88. However, we are at 500. So because our temperature is greater than T sat at 1000, we are a superheated steam, right? So we're not on the saturated mixed state. Instead, we're superheated, right? So and that's because obviously 500 C is greater than 179 something. I think so. Yeah, 79.88 Celsius. Okay, so therefore this is not the right table for us. The right table for us is a superheated table. This one is here. And here what I want to look for is on the temperature side, I want 500. So I want this guy here. And then on the pressure side, I want 1000. So 1000, this is not what I'm looking for. I'm looking for 1000. Where are we? Here we are. 1000 kilopascals or 1 megapascals, and this is 500. So I'm looking for these properties here. These are the ones that interest me. And specifically the one I'm looking for is the specific volume. So this is the one that I want, right? So if with this information, which is the crucial information here, I can go back and calculate what is my volume, right? So 0.3, let's write this down, 0.35411 is the value of interest here. Okay, so we found out the state, or superheated state. We got the specific volume, so all left to do is calculate the volume. And I can do that by saying the number that I got before times the mass should give me the volume that I'm in question, right? And this gives me 0.70822. We can approximate that to 0.708. And in terms of units, we can check, right? So we're doing meters cubed per kilogram times 2 kilograms. So therefore, our units are meters cubed. Okay, so this is the volume occupied by 2 kilograms of water in the superheated state. All right, so like I said, straightforward problem. If you have any questions, leave them down below, and I'll be happy to assist you. If this video was useful and helped you, consider giving it a like, and we'll talk soon.